All right, and we're off. So, thank you everyone for joining. Thank you everyone for inviting F5 to this forum. My name is Corey Marshall. I am the Director of Solutions Engineering. I lead a team of Spec Ops cybersecurity warriors dealing with security, edge, and DevOps. So we like to call ourselves the All the Things Group or DevSec Edge Ops. And today we're going to talk about how do we build a zero trust access framework in 2021 and beyond. And so I like to start with that. What is exactly zero trust? It depends on who you talk to, right? So there is a lot of marketing out there, everything from Google to Forbes, Forrester, Gartner. Everyone has an opinion on what zero trust is, right? But yeah, what I like to the way I like to look at all of the different information that is floating around out there in regards to how do you implement zero trust is that we're dealing with a situation where we're having to modify the way in which we do IT architecture, operations and engineering on the fly, while we're actually running the ship, right? So we're building and running the ship simultaneously. And with that, when I look at all the models and frameworks that are out there, they're goals to aspire to, but we have to keep the ship running simultaneously. So that's why I say when it comes to zero trust, let's start with the things that we have and that we can build upon, right? So if we start with the skeleton of a lot of the investments that we've made in terms of security and infrastructure technologies, we can indeed start to shift towards true zero trust architectures. And so when we think about zero trust, let's think about the very perspectives of the people in the organization, right? So we're dealing with an architectural concept, not a single product, not a single market, where the people who are writing the applications and the people who are leading different components of the infrastructure security practice are thinking about very different things. So you say zero trust to developer, they're thinking about microservices and service mesh technologies. Security leaders are thinking about visibility and advanced, firewalls, microsegmentation perhaps. And then, the people who may be leading the networks are thinking about, how do I deal with, connectivity and, how do I wrap software defined perimeters around networks that I no longer own? And so you think about going back to NIST and some of the CISA guidance surrounding capability models. What we did at F5 was say, this is what the customers are asking for, and these are all the places where we map in terms of an F5 solution. I won't spend a lot of time here, or we would be here for probably a couple of days, but that's to say either we provide a large portion of the capabilities from a capability model in terms of the core pillars, or we integrate with those capabilities. And so we also provide a mapping that we can provide to you after the meeting in terms of exactly which controls map to which solutions from an F5 perspective. So let's talk about a technology spectrum, right? So let's take a higher level view. Remember, we're dealing with different perspectives. So service control, my developers, network leaders, maybe microsegmentation, maybe security leaders, the identity teams dealing with user and entity access. And so we're going to focus on the user and entity access because this is where, if we dig into the NIST model, like our friends at Okta did, this is how we map in. So the first thing at the core of the model is what's often lost between different organizations is this concept of control plane and data plane, right? There's some blurring of the lines, if you will. And so when it comes to the actual data plane, I would argue that this is the actual most important component. So the capability of the data plane to actually impact and control the traffic that's on in the environment is key, because without that, first of all, nothing ever gets through to the back end. And then what we have in terms of control plane is something that is interchangeable, right? And so when it comes to the supporting features surrounding my device posture assessment system or my device management solution, there's solutions from F5, there's solutions from third parties. My PKI solution, my identity management or IDaaS, for example, Azure AD or Okta, or hey, where do all my logs go? Where do my analytics go? And then including things like threat intelligence. So this is another key component. And if you look at organizations, especially governmental organizations, you have mounds and mounds of threat intelligence that you're unable to use in a proactive manner, meaning that oftentimes you can go back and retroactively apply that intelligence to, for example, a transaction or an access that happened, but in real time, leveraging that threat intelligence has proved to be a challenge, and not just in government, but in enterprises as well. And so with F5, what we've strived to do is have a data plane that we can integrate with various control planes, including our own, so we can act as a policy decision point and a policy enforcement point. But moving beyond that, we can also integrate with external sources of data. For example, Open Policy Agent, a declarative policy engine that we can plug in with out of our data plane to affect policy. So maybe your threat intelligence, maybe your entity controls and status are flowing into Open Policy Agent, and then the data plane is just leveraging that information. Again, all API-based integrations. And so, what's the outcome we're driving towards, with this model? And so first thing, access to services not determined on your network. Second thing, that access is granted based upon contextual factors, including but not limited to the user, the device, the application, and the infrastructure itself. And of course, all the access must be authenticated, authorized, and encrypted. We'll talk a little bit more about that later. And of course, this built out wrong, but the architecture must be highly extensible. Why must it be highly extensible? Because especially in our brownfield environments, again, we're building the ship as we're running it, if you will. We have to be able to deal with corner cases, all right? And then especially in government, I bet there are a lot of different corner cases, but we have to be able to mold the data plane and the control plane to be able to accomplish things that we didn't originally conceive in terms of the solution for the market. So that extensibility tier is very important. So let's talk about some architecture options, right? To give some history when it comes to user access. And so, first, option, that you see, quite a bit, microtunnel based architectures. And, I don't care what anyone says, but this is essentially next generation VPN technology. So multi-point VPNs that operate oftentimes at layer 4 instead of layer 3, meaning that, I didn't have a full network tunnel oftentimes per se, but I'm still tunneling traffic or encapsulating traffic in an encrypted manner that reaches gateway, which de-encapsulates that traffic to reach the endpoint. Then we deal with proxyless or code level integration, zero trust. You may see this in a vertically integrated system. I don't know what the launch controls for the launch of Hellfire missile off of Predator drone looks like, but I imagine that's fairly vertically integrated. And then identity aware proxy. So identity aware proxy, just as a piece of foreshadowing, I believe is the place where most organizations can get the fastest ROI from an investment in a zero trust framework. We'll talk a little bit more about that. And then microsegmentation, right? Not access technology in and of itself, but related technology can enhance different architectures. So my microtunnel architecture may look like this. It looked like a VPN technology where I have an endpoint, I have a gateway, and then have all my applications. And so in today's world, for the most part, when you connect over VPN, I am then dropped into the network as if any other device on that network. In terms of enterprises and governments, most organizations' networks are not properly microsegmented. And so when I get access to the network, I have broad ability to compromise systems on that network. And so the microtunnel architectures take a different approach. It's usually unidirectional traffic and it's multi-point. So meaning that I can deploy those gateways in more places and take the shortest path approach to those gateways. And so in terms of pros, I can oftentimes deal with most TCP UDP applications. Example was this, maybe Zscaler, but um, when it comes to what actually is happening in the background, remember, we're still dealing with tunnel-based overhead, right? So I like to call this hashtag slow. So depending on the application and the latency requirements, latency jitter, things of that nature, it will definitely be a little bit slower in performance than something that was not encapsulating traffic. And also, when we look at where the actual threat surface lies, right? Applications and identities, right? If I'm doing my controls based upon kind of my next generation network extension technology, I'm kind of missing the point in terms of if you gave you an analogy, if you've ever gone ice fishing, you walk out on this frozen lake, you drill a hole, through the ice with an auger, right? If you're looking above the ice, it's completely lifeless, not much activity happening above. But when you get down into that water, that's where all the activity is. And so if you can imagine, if I just controlling access into the network, but not actually looking at the actual traffic, right? So layer 3, layer 4 versus looking at layer 7, I'm kind of missing where all the action is, if you will. And so one way in which you can enhance these architectures is by implementing microsegmentation in addition to the microtunnel architecture. Again, this may be appropriate for some organizations and for organizations that can tightly segment their internal network. But again, this is, I would say that the microsegmentation is a best practice regardless of what access technology you choose. So we'll skip past proxy code level integration. Okta actually mentioned this, and they have this capability as well with some other vendors on the market. But oftentimes I look at this as this is not necessarily for some COTS applications, right? Especially when you have to have an agent that you install on the application and its servers and various components. It doesn't stop the traffic before it reaches the server and application, and there's implications associated with that. And the technology though is easy to deploy. The DevOps people like it. This is the auth zero type of approach where everything is vertically integrated in a single package. But again, we're dealing with brownfield here. Then we get into IDWare proxy, right? So you may have you may have heard the term IDWare proxy because Google has popularized the term via the BeyondCorp project. However, BeyondCorp IDWare proxy may look very similar to microtunnel architectures, except I'm not actually tunneling any traffic. Well, what's the caveat to that? Well, oftentimes I'm not able to deal with other things other than web applications, right? Depending on the solution in the market, F5 retains the capability to actually tunnel traffic as well. So we don't have that limitation. And then we'll have specialized proxies for things like, RDP, web SSH, or the ability to tunnel those protocols, any TCP UDP protocol. And what you do is you authenticate the tunnel and you de-encapsulate that on the gateway itself. Also, when it comes to IDWare proxy, remember, we're looking at the life that's happening underneath the ice, meaning that we're delivering tight or granular fine-grained controls based upon the actual identity, device status, and the application itself, right? So I can plug into the layer 7 flows of the application and be able to provide things like contextual single sign-on, be able to modify data that's within the data stream if I need to. I can do contextual step up and MFA access, for example. We'll talk a little bit more about that. But with this, we go back to user experience. User experience and productivity is often key to customers. This technology allows me to leverage the protocols as they were intended to be leveraged. However, doing that while not losing any of the security benefits of dealing with tunnel-based access. And so what's allowing us to do this, right? Why hadn't we done this before? And this goes back to the way in which your applications actually work. So applications today and proxies today often function on what's called a per session policy, which means that once I'm authenticated and authorized, whatever whatever risk that I had at the time that I was authenticated or authorized, or what my group memberships were, or whatever contextual information that was measured. So, for example, if I was on a consumer network, not coming from a Tor exit node or anonymous proxy at the time of authentication, that is what it is, right? Versus we now have the technology to shift towards a per request policy. This allows me re-entry into an access decision without interrupting the user experience. So this provides me the capability to do things like step-up authentication based upon a change in context, for example. So the context may be, hey, this device or this user had a session with an application, but then we see the traffic is now coming from an anonymous proxy, or their session has migrated and shifted to where it's coming from a cloud provider network, which would typically for a user would be something very unusual, or what they're accessing has a higher risk associated with it, or maybe we've had a push into the proxy, or the proxy's queried the risk engine after a timer's expired, and the risk score of the user has decreased, for example, right? So any change in context, I can re-enter into that access decision. I can take an action such as block or quarantine that access, and I can do that on a request by request basis, right? And so that technology in and of itself allows me to really start to address the challenge of continuous trust with zero trust. So, and the way we do that at F5 is that we have what we call a visual policy editor. And this editor, it looks like a branching flow chart. And so we step through each and every access decision via an agent. And by the way, each and every decision and the activity associated with that decision is logged. So you may say, hey, I want to present the user login page, or I want to send them to an Okta or an Azure AD for authentication. And then once that happens, I want to take their attributes and I want to screen their access to a set of resources, depending on who they are, with internal contextual attribute information or external data as well. So there's things that from an access proxy perspective, there will be things that we learn from the identity provider. There will be things that we know out of the data plane from the actual traffic itself. So for example, hey, this user, if you integrate our WAF module, they're authenticated, they're appropriate for access to the group membership, but they've also been sending us some SQL injections, for example, or we know that initially they had one IP address, and then when they switched to they changed their IP address because users roam, but now their session seems to be coming from a Tor anonymous proxy. So perhaps their endpoint was compromised, their session's been hijacked, and now a threat actor is attempting to leverage that session for access into the network from behind an anonymous proxy, for example. And of course, let's take some action based upon that. Or, their endpoint device has fallen out of status. When they initially connected at 8 a.m., they were leveraging the application. Everything was fine. Their device posture was clean. And then at some point, throughout the day, we saw that their device posture was no longer in compliance. And now let's take an action again. And that can be done in the background without the user's interaction. So let's shift to some examples, right? And so when it comes to integration with IDaaS, one of the pieces that I think is lost upon a lot of people when it comes to how do I bring the cloud identity, or maybe my legacy identity that may be an Active Directory or LDAP, or maybe even a database that's fronted by REST API, for example. How do I bring that to my applications in a way that the applications understand? And so at the access proxy layer, what we want to do is transition that identity from one form to another. So if it's SAML or OpenID Connect facing the identity provider, perhaps the application requires Kerberos. Perhaps the application requires Radius or a JOT token. Perhaps the application requires a dynamically generated X509 certificate, or even something custom. The access proxy, in the case of F5, has the ability to do that. But there's another piece from a security perspective that people don't think about, which is those applications themselves. All of them implement their access frameworks differently. So they're doing their own session management. They're doing their own authentication. They're doing all authorization. And so if I had an incident involving an identity, where I have a user who could be accessing hundreds of applications or dozens or hundreds of applications, how do I now stop that user or that session from being able to access any of the applications? Well, you can't, because if you disable them in the directory, well, they already have a session with the application. The application is not re-authenticating them. So this is where the access proxy comes in, where I make an API call to the access proxy, and all the authentication is stopped at that point, or all the sessions for the user, right? So nothing can hit any of the backend applications. However, in addition to that, look at the access proxy as an identity firewall, meaning that I'm going to have a hardened or a normalized engine that accepts all the authentication authorization requests from my untrust and protects my applications and maybe any issues that I have with or vulnerabilities I have in the access framework in those applications from that untrust zone, right? So nothing authenticated hits the backend applications. They only hit the hardened front door. Yeah. So if taking a look at the architecture, it may look a little bit more like this. I indicating Okta as an IDaaS provider here. I can place those access proxies in both in my cloud environment or on my on-prem environments. I can integrate that access proxy with one or more MFA solutions. So it's not a selection of that I have to pick a single tool in every tool set, for example. So for one application, I can be integrating with Okta, another application, it could be Azure AD, another application, it could be an LDAP directory, or for one application, you may have attributes for user across all three, right? So I can leverage multiple components at each and every step along the way, and including, of course, MFA, right? So you may have users that are in leveraging Duo today, and maybe they're transitioning to Okta or transitioning Okta or Azure MFA, or maybe different departments have made selections of different MFA solutions, and we want to leverage them both through a common access proxy. We have that capability. So again, the extensible ability of the access proxy to almost be a piece of middleware in addition to the proxy itself to be able to bring together all the components. So talk a little bit about flows, right? And this is just an example flow. Different workflows could take place. So in this workflow, the user is going to access the application. Number two, then the page based upon perhaps some information that is embedded in the certificate, the device or user certificate. Maybe we'll do an MTLS challenge with that device. And then we take the metadata from that and we leverage that to maybe query an API about user or device status. Then authenticate the user against an IDaaS or AAA solution on-prem. And then, number four, very interesting one, leverage, APIs for third-party security solutions. We call it API or HP connector to go in and pull in additional contextual information. Now, oftentimes we talk about pulling in information. However, what about the availability of information to an AI or machine learning solution to continuously build their model, right? So if I want contextual data from all the applications, I would have to go out and instrument all those applications to be sending information to my machine learning solution. And the access proxy provides a great place to provide all that contextual information in terms of logging to that to the API. So it's a push-pull relationship. And oftentimes it's just something simple as, hey, here's a block list, here's a risk score, for example, where to pull back that contextual information to provide access to an application. All right. So any questions so far? All right, no questions. All right. So one of the things we want to talk about also is security within the data plane, right? So when we think about, again, where the vulnerabilities sit, the actual applications themselves provide much of the attack surface. And so in concert with the access proxy, you can also run the web application firewall, where we're inspecting the actual payloads of the traffic to ensure that nothing malicious hits my backend application. So a typical WAF will do things like OWASP top 10 mitigation, inspect that traffic if it's encrypted, maybe have a programmability element to it. But in addition to that, the WAF is able to look for automation. Right. So there's something called, proactive bot defense, for example, where if we're expecting a user with the browser to access the application, but we're seeing automation against an application, we can prevent that automation from ever hitting the backend application, protecting the credentials within the browser itself. So there are technologies that we offer from F5 that actually extend your zero trust perimeter out into the browser itself to look for things like malicious JavaScript that may be running in the browser itself and stealing data, right? So if you think about your security architecture, normally the gateway wouldn't see anything that's happening on the client side. So what we provide is a couple tiers of technology to not only look for automation, but also look for what's actually happening in our universal client, that browser, if you will. And also one of the pieces in terms of protection is to be able to actually encrypt data within the browser, for example, as the user is typing it, right? So if they're typing a username and password into a form field, can we encrypt that data as the user's typing it such that, if there is a party that's able to intercept that, or there's a party that is attempting to steal that out of a browser, we want to make that that much more difficult for them, right? Because one of the things we know is that when a user goes out and they go out into the world, they go in Starbucks and they say they launch a portal site and they see an SSL TLS warning message. Well, what do? Right, they click right past it, and they say this is fine. I'm pretty sure you've seen that meme, right? And so what we provide is an extra layer of protection for that confidential data, that credential or credit card number or a piece of PII that a user's entering into a form field for being intercepted on the wire. There is a concept of dealing with application layer denial of service defenses. So a lot of the government's networks, I'm sure, have very, very good layer 3, layer 4 denial of service mitigation. But how about layer 7 denial of service mitigation? So what does that mean in a federated world where the consumption for identity is also a web service, right? It's a layer 7 service. Or there's a set of APIs. So I need to be able to deal with denial of service attacks at layer 7, which may not be bandwidth related, but nevertheless cause stress on the application. And so provide the ability within the data plane to look at the performance of the application. So we're profiling that over time, of course, using machine learning, right? Because how do you find a needle in a stack of needles is machine learning. So machine learning that's running in the access proxy in itself, looking at the performance of the application over time, understanding for each and every request, how long that takes to return that request, what's the latency, what's the queue length, right? How many requests have I sent you versus how many requests I've gotten back? And when we start to see the stress metrics for an application continue to rise, we're able to look at what's causing the stress on the application and only mitigate what's causing stress on the application. So very neat layer 7 denial of service solution there. Dealing with threat campaigns, right? So it's one thing where, for example, WAF, specifically our WAF, has both a negative and positive security policy where it can not only look at what's known bad, right, through signatures via protocol compliance, for example, but also look at what is known good, right? So actually learning the structure of the application, learning what the input fields are, the character sets, things of that nature. But with that, what about what's actively being exploited? And that's where threat campaigns comes in, and the threat campaigns look at what attackers are actually targeting during that very moment. What are the campaigns that are happening, and then providing that information as a feed into the access proxy or the WAF itself. Credential stuffing as well. So credential stuffing, dealing with denial of service, or dealing with brute force attacks or credential stuffing attacks for access to resources is something that the WAF is able to track very closely. And there's a couple levels of service that allow us to do that. One of them, I believe, time given, I'll be able to demo for you here. And then last but not least, API security. So if we go back to the way that applications are written and we go back to kind of, per session versus per request policy, well, most of your applications today are, leveraging per session mechanisms, and that's fine because hey, I authenticate to the application, I get a session cookie, and and I'm able to use the application for the life of my session. Now, when it comes to the way applications are being rewritten, that they're oftentimes being rewritten as progressive web applications, meaning that I've loaded a framework for a page. I have a piece of HTML or CSS, and then I also have a set of JavaScripts. And what happens is that if you ever landed on a page and you don't see the URI changing as you navigate through the site, that's an example of a progressive web application. So underneath, it's actually making API requests to a backend to retrieve or transact the pertinent information with the user's interface. And so API security is key to the access proxy as well. We have to be able to protect APIs, and that requires us to do some slightly different things because it is sessionless, right? So I need to be able to have a per request security strategy versus a session-based security strategy when I'm dealing with API security. All right, questions on that so far?
Looks like there's one question from David Austin. He's asking if you could clarify, are you saying that you can detect and protect from keyboard replication from stealing passwords?
Keyboard level, no, because that's beneath the tier of the browser, but we can help protect in a browser. Yes. So, for example, if if you think about a supply chain for web application, you're oftentimes dealing with a lot of third-party components, and somewhere down the line, one of those components can be compromised. All I need is one piece. So, for example, I'm running a web framework that does some dynamic user presentation within the browser, and oftentimes developers, they just link these libraries without thinking about the security chain of those libraries. So what an attacker does is that they compromise one of those components, and now every time someone loads that page, they're running their code, and with that they might be able to steal, for example, a password, for example. And so what we're able to do is we have our own script that actually runs within the page. So what happens is the page is loaded, for example, authentication page. Our script is going to run, and it's going to intercept the user's credentials and encrypt them with a key that was loaded from the proxy itself. And then when the login transaction happens, or for example, a form post with a PII data, for example, the proxy will decrypt that and then reconstruct that request to send to the backend application. And of course, there's things, keys are rotated and pulled, and there's anomaly detection techniques, because one of the things that if we're doing this activity in the browser is, can you work around it with another script? Yeah, potentially, but that requires you to interact with the DOM, right? And once you interact with the DOM within the browser, that can be detected as well, and that would be another anomaly that that could be detected and leveraged to make an access decision. But great question. All right, so let's think about when it comes to how do I take the next step of looking at separating or separating malicious users from good users, right? And so this comes in the form of different risk engines, but what are those risk engines doing? Well, from everything from sign up to actually performing the activity or transaction, we want to be able to look across that user journey and be able to make the appropriate access decisions. And so with that, what are we trying to accomplish, right? So this is maybe from a consumer or from a constituent access perspective. Maybe it's creating an account, or as they're leveraging the information, are we performing continuous authentication? Or for example, are they performing payments? So this might be a thing for IRS, for example, making sure that data is not intercepted. But all of these capabilities really center around that user journey, and the risk engine itself is able to contextually help us, again, decide where our users are on the risk spectrum and decide what actions we want to take based upon that. And so, for example, for users exhibiting suspicious behavior, perhaps we challenge them at their logon, or perhaps we prompt them for MFA, for example, with an Okta. Or maybe it's an unknown user, unknown device. We haven't seen this before. Maybe we perform the same authentication steps. But if we're leveraging the risk engine, we have confidence and legitimacy, no suspicious behavior, then maybe we perform a standard logon. And then for high confidence, maybe we're able to bypass login altogether, right? Or accelerate or perform session extension. So they've had a previous session, and do we want to slow them down and force them to log in again when we have high confidence? The AI and the machine learning engine, the risk engine is telling us that this is a known user, right? And so what helps us do this is that there's always unique telemetry differentiating users. So these are network signals, the digital identity of that user. So that is either the device fingerprint or other information surrounding that user and identity. Behavioral biometrics surrounding that user. So the way in which they leverage the application, their movement patterns, their typing patterns, uses autofill, their screen utilization, and of course, behavioral profiling as well, right? So what does their actual activity look like? What's their diurnal cycle look like in terms of how they actually access the applications? And so with these things, right, we can build on those signals of history, uniqueness, and integrity to provide insights into the user's traffic and help security teams detect anomalous activity. So, for example, we were saying deliberate use of proxy networks. So, well, maybe we see that based upon fluctuations between IP addresses and the device IDs. Or maybe we're seeing, a single device accessing unauthorized accounts, right? So we see fluctuations in the number of users per device ID. So we see one device, but we see it try 20 different user accounts over a long period of time or a short period of time. Or we see things like session hijacking, so fluctuations of device ID per session identifier. I'll give an example of a solution that we're working on for a payment provider, because they had a unique challenge of, hey, how do I prevent session hijacking when I'm dealing with OpenID Connect flows? And so can we tie in device ID and have that information validated and signed, but can we also tie that out of band with the actual measured device ID at the time of access, right? And so that helps with preventing session hijacking. So you can't just take their access token, put it in another browser, or put it in a bot and actually leverage that. It won't work. Okay. So what we focus on is, of course, preventing those malicious actors across the entire user journey. Won't spend a lot of time here, but I'm going to show you a demo of actual invisible MFA, where we're actually looking at the user logging in and performing access, and then having a change in context, and then seeing if that user is allowed on again. Right. So with that, let's do some demos. All right. You stop sharing for a moment there. Any questions in the meantime while I'm prepping that?
And you can put them in the chat too if you'd rather type them out.
Yeah, in chat.
Yeah, this is Dave Austin from Fusion. I've got a quick question. When users are, they get authorized and then you want to tear them down from a particular application, what kind of maintenance timeline is going with that? And do you have the ability for that not necessarily to be an admin, but a manager of that person, so that you can get some more fine grain on what they're authorized?
Yeah, you can absolutely build that into a framework. There could be a few different ways to do that. So one of the things that you could do is that it can be very simple to where I build the framework and access proxy where I match the attribute to the application. And so that can be locally on the access proxy using something we call a data group. It's a fancy term for a table. Or you can, by the way, which can be, pushed into an updated externally, right? So maybe there's some other process that's running externally, and we push down this table that's doing the mapping of group to application, or you can use something within the policy itself, or you can use something external like an open policy agent, for example. But the whole goal there is that, hey, I have an attribute that grants you access to an application. And then if I remove that attribute, can I remove your access to the application in real time or near real time? And the answer is yes, because when we're following a per request strategy, even though the user has a session with the application, they can be using it actively now. What we have is something called subsessions. So what happens is that based upon a trigger, for example, a change in context, say it's IP address or just a change in time, where you say, hey, go and check this user's group memberships every 30 seconds. So within that 30-second window, if that group was removed from the attribute set, but that group was actually required to get access to the application, we would stop that. Right. And so go back to the original question, if you need it for a manager to be able to control the access for that user, it would be as simple as, that manager is interacting with whatever IDaaS they have, or they make a request in your ITSM solution that says, hey, remove the user from this group. When that happens, the access proxy will see that and remove that access, even if the user is actually using that application. So we don't have to wait for that user to sign off and sign on to provide new or more restricted access. Did that answer the question, Dave?
Yeah, yes. Yes and no. I guess it sounds like it's going to take a lot of maintenance. The whole notion of zero trust is pushes a lot of what I call maintenance if you want to have any kind of close control on the trust on at the application layer at level 7, basically.
Well,
So
yes and no. It
experience
depends.
with your customer.
Oh, go ahead, Dave.
So, from a maintenance burden, what is sort of your experience from your customers? Is it relatively light?
Yeah, it depends on how deep you want to go. So with the access proxy, you can go as deep as say, hey, specific users can only send specific kinds of requests in application. We can literally look at, what are the parameters in the request, or is this a get or a post request or put, for example, and control that access very granularly, right? But most customers go with, hey, I want to make sure that nothing authenticated and nothing with a negative device posture or a certain risk score, or something else from a risk engine in terms of block lists, or maybe they have CrowdStrike, or they have some other EDR solution. They don't want anything anomalous to ever hit any of my applications. That's the first thing we go with. And then the second thing is, okay, only certain users get access to certain applications, right? And then you go a little bit deeper. Well, now only certain users can get access to certain applications at certain times of the day. Okay, well, now when we get into the context of an application, what actual requests can they make against that application, right? So depending on how deep you want to go, that will be, of course, any kind of maintenance burden, right? Because it's the application's change. But I recommend to customers that you think about it in terms of, how do I build a framework such that I don't have to touch this again, or I'm looking at the actual processes in the organization. Well, how do application changes happen? How does application onboarding happen? And if there needs to be a change in the access proxy, can we plug that into that pipeline for the application deployment, right? So once I build that framework, you shouldn't be touching the access proxy that much, unless you want to do something very, very specific.
Yeah, thanks. That helps. Just just build it in the pipeline when the app is changing. That's a good direction.
Yep. All right, so we're gonna do a couple demos here. Just shifting some screens around. Anyone need a bio break or anything? I know I've been talking for quite a while. Oh, it would help if I share my screen. Yep. All right, does everyone see my screen?
Yep, I can see it.
All right. So what we're going to do here is this is maybe just representative of a typical user's desktop, and we're going to hit play. So in this case, I chose this because Okta went before us and wanted to show us integrating with Okta. So what happened here is that the user, all they did was attempt to connect to an application. They were redirected to Okta. They're going to go ahead and sign in. You just sign in as Okta user. All right, good to go. And now they got access to the application, right? So single sign-on, meaning that, by the way, this application on the back end took a different authentication technique other than SAML. So we took that SAML off and translated it into something else that the application understood. So first step. Well, of course, the user's not accessing one application. Maybe they have many applications. So what we want to do is let's look at something where, in this case, we're actually going to change the user's posture, right? And so in this case, the proxy requires us to be in a good posture state with the firewall enabled before we allow access to the application. So the user's going to turn off their firewall. And they're going to refresh that page. And notice that we have now blocked that access. And the way this is working is that we're actually there's an agent that's on the machine in the browser that's actually including the device posture information in with the actual request to the backend. And this is, of course, one of the ways in which we can accept the device posture. So this is an in-band mechanism, and of course, we can do out-of-band mechanisms as well. Right? This is using our agent, and which is leveraging OpSWAT underneath. All right, so user's going to go ahead and say, "Oh, I've done something bad here." And by the way, when they did this, this is of course logged, right? And so based upon this log and this action, maybe we showed them this message, and then maybe redirected them to the to your organization's compliance page, or open up a ticket that got shot to their manager, for example. You can actually do that. All right. When they turn back on, refresh the page. Oh, okay, I'm good now. So let's go to application 2. Now, in application 2, we had a different risk posture, right? So application 2 said, we had a policy that said, hey, I want a certificate for this application, right? And so in this case, you got prompted to select a certificate. Depending on how you deploy those certificates, the browser can auto select that certificate, so the user wouldn't even see it. Just as a note, something else in terms of the access proxy, going back to the original single sign-on mechanisms, the F5 access proxy also has the ability to dynamically generate client certificates on the server side. So meaning that the client's gonna, in this case, going to provide a certificate that's going to be consumed by the access proxy. Well, what if the backend application also requires mutual TLS authentication? Well, what we will do in the access proxy is that we can dynamically generate a certificate that's leveraging the attributes from the original certificate. So, for example, if this is a 1-year certificate, maybe we'll generate a 5-minute certificate, and then we'll use that in the mutual TLS negotiation with the backend application. So, very, very, very neat feature there. All right, so application 2, we're in. We'll go to application 3. Right into the application. And again, all these applications could have different access criteria, and they can also be leveraging different sign-in techniques at the actual application themselves. Right, so really quick, I'm going to jump into the BigIP. And by the way, right, this is going back to what do organizations have in their network, right? How, when it comes to building a zero trust framework, do I have to redefine, rebuild everything, or can I leverage what is already in my environment? And so these F5 devices happen to be in front of many, if not most, of an organization's applications, right? And for organizations that are F5 customers, they're at the edge, they're at the core of the network, they're in the different security enclaves. So with the license, I can start enabling the zero trust access capability and identity policy based access with infrastructure that I already have, right? So just keep that in mind as you're looking to, how do we get started? How do we start rolling out zero trust and enhancing the security within the environment or from a remote perspective? All right. So we have a template called guided configuration that went pretty fast. So once I click on that, it takes me through, it shows me a set of use cases here. All right. These are just, consider this a wizard, right? So I can build these configurations, by hand. I can build them using the guided configuration wizard, or I can, we have APIs that can be leveraged as well. And so in this case, I'm going to use the wizard. And if you look at the wizard, it's going to walk through a series of steps of what we want to define to provide access to an application or set of applications. So this is something else as well. When it comes to the access proxy, is that because I can run it on the ADC, means that not only am I handling the identity component, I can also handle the load balancing and the web application security component of it as well. However, when it comes to getting access to or proxying access to the application, think of us as a combination forward and reverse proxy, meaning that you can point explicitly to the proxy to provide access to specific applications. And so you can have a set of DNSC names that point to an A record. So, app 1, 2, 3, 4, 5 point to proxy dot agency.gov, for example, right? And they would hit a single listener on the proxy, or you can expose those applications on a per application by application basis. So just a record points to a listener, and each application have its unique listener. So what we see with most customers is that there's a mix and match. So they'll have a set of applications that flow through a single listener, and then they'll have some applications that have a unique listener. And so here we're just saying we want the firewall check in place. That's enabled. That's using the F5 posture check. Again, we don't have to use ours, but in this case we are. That supports Chrome, Edge, and Firefox, looking at antivirus, hard disk encryption, file share, and patch management. And it looks at that every 60 seconds within the data plane. Next thing was, I know we skipped over some components there, but we looked at SSO. So this case, it was just one of the SSO mechanisms defined was Kerberos. We had a list of applications, what that pointed to, and any monitors associated with that application. Right. And notice that an application could be the application FQDN, or it could be a subpath on that application as well. All right. And then we have application groups. Now, this is interesting, right? Because when we define a set of access criteria, for the most part, there will be applications that follow a similar workflow for access to an application. So these applications require Kerberos. So OIDC in the front, Kerberos in the back end. Then there may be a set of applications that are OIDC on the front end and OIDC on the back end. So what we want to do with those, maybe we just want to validate the token and validate the attributes or the claims in the token before we allow access, right? So maybe it's the original token from the IDaaS flowing through the access proxy, but being pre-validated before it hits the actual application itself. So what we would do is put all those applications in groups such that you don't have to define the access mechanism for each and every application. Right. So app 2 and app 3 have the same access mechanism. And then contextual access. So in this case, perhaps there's applications that you want to allow access to, for example, the device remediation page that doesn't require their device posture to be good, because it kind of defeats the point of having the device remediation page if their device already has to be compliant to get to it. So in this case, only application one requires a firewall check to be enabled before you get access. And then the other application groups or applications don't require that posture check. But if you notice here that, application one, application four use Okta, and then application three uses a certificate. All right. So we'll get to the end there. Just highlighting some of the config that was done. And once we get to in here, we just hit deploy, and that gets deployed, and it gets deployed, and now I have deployed access proxy. Right, I deployed access proxy and did that for 4 applications and do that in about 5 minutes. And by the way, once I do that, there's a couple different things here. So one, if you see this lock here, right, that means I want to leverage the templatized configuration. But if I want to do something that is more complex outside of the template, I still have access to all the policy components that are not in the template. So I can do much, much more sophisticated access decisions by just going into the policy itself and editing from there. So oftentimes for more sophisticated customers, we just leverage this as a starting point, lay down a base configuration, and then go back in and edit the policy. And by the way, those policies are now also exportable. So I can take those policies and export them in onto all my different access proxies. So define once and use many. All right. So that's one demo. Any questions on that? Let me shine. All right. So let's we'll go ahead and we'll get rid of that one. Let's move on to the next demo. Hold on, that didn't go right. All right. So this one is an interesting demo in that what we're doing with this demo is that we're actually doing a leak credential check, right? So in this demo, we're actually taking a login credential and we're querying that credential against an external API and that API is looking at whether or not that credential has been leaked and is a compromised credential that was found on the dark web. And so of course, that can be you can leverage that external API functionality with virtually any offload. But in this case, what we're going to do is, once you hit this login object, it's going to run all these objects. So login page, we'll set the variable for what needs to be sent to the API. We'll query the API with the hash of the credential that is. If the credential was exposed, we'll log a failure, right? And then we can send it on, right? So this was not meant to actually block the request, but simply log that if it was a compromised credential. And so in this case, not exposed, send the AD auth, and then if AD auth is good, I hit allow. Once I hit this, come out of here in this allow branch, I'm allowed access to that application. So. All right. So this is showing a lot of how this is actually working, but let's go through to the login. So I'm a unique user. I'm going to sign in. All right, unique user. I landed on the portal page and access to a bunch of applications. That's fine. And so from a log perspective, we see that I generated a subsession where I query the API. And this is showing all the metadata associated with every step along the way. So we saw that credential existed in the database. That was a false. All right. All right, so we're gonna log in, log out, and we're gonna log back in with another credential. John Doe, let's see what happens. All right, so in this case, we saw this compromised credential and we forced the user to change their password. All right, so if you can imagine this in an organization where, say for example, you wanted to force a password change on users as a result of an incident that happened, you weren't sure if all the users' passwords are compromised. The access proxy can actually force that, and so we can you put that information to a database, for example. We look at that and then we force users to change their password, for example. All right. So that's another demo. That's any questions before we move on to the next one? All right, no questions. Pardon me there. 1 second. Okay, give me a second here. I don't know what is going on.
Yes, we can hear you.
Can you hear me there?
Yep, we can hear you.
All right, give me a second here. It's just I had to move the file because for whatever reason it's not playing. All right, so while that one's moving, apologies there, let's go ahead and do another demo. In this one, so this is another demo that shows looking at reading and writing data from an external data source. And so we think about the architecture using attempts to connect to an application. We want to call out to some other service to actually get some additional information. In this case, the user is going to log in. They're using just a local auth in this use case. Again, it could have been something federated. So in this case, the user logged in, and what we did was we retrieved a set of user attributes from a REST API. Right, so the user's into the application. What we're going to do is we're going to change something about the user. So we disable this user. Right, so why might the user get disabled? So if you think about user self-service, something happened. Maybe they exceeded the number of passwords attempt. So this is like a self-service password reset, or perhaps a security administrator wanted to disable them and force them to walk through a process. And so now when the user signs in again, all right, oh, there we go. The user signs in again, their credentials have been revoked, right? And so you can give them an option of different options. So in this case, we gave them options of try to unlock. And with that try to unlock, we say, hey, what can you provide? So maybe there's questions that we can retrieve out of the API itself, or maybe there is, hey, we just want your client certificate, right? So if you can provide your CAC PIV card, for example, then maybe we'll unlock your credentials, right? Or maybe you do both, right? Give me an answer to a question and your CAC PIV card. In this case, we just say, hey, give us your driver's license number. And they were into the application. So that was just showing that the user, once they unlocked their account with the driver's license, that was re-enabled, and we went back and disabled it so that we can show them actually providing the client certificate this time, providing the client certificate, and the account's unlocked. And when we go look at the directory again, we see that that user is unlocked. Right. And the way in which this looks from a policy perspective is actually very, very simple to put together. So we see that, hey, we have a connector. I've defined a transport for it. Here's a URI, here's a method. It's get that I need to authenticate, and then what the request headers and body that I want to send to the API, and then the response. Do I want to parse the response? And when I parse the response, I automatically set the responses into session variables that I can then leverage to make the branching access decision. So this is what that policy looks like. Right? AD authentication, show the user's attribute, the unlock AD accounts, and the change based upon driver's license. So again, much of this functionality, it may look sophisticated in the way this works, but provide all the framework for you to build out these workflows and be able to do that very rapidly, right? So someone could put this together in a very short amount of time versus if you had to do this building this from the ground up. All right. Any questions on that one? All right, so that was another data integration example. And just give me one moment. We're almost there. All right. Get to the appropriate place. All right, so another demo, the last demo that we're going to do today is what we're going to do is an invisible MFA challenge, right? And so what we've done is, how do I tie in a machine learning solution with actually my client application? And so what we have is an actual portal. And so this portal has since changed, but what it's called is Recognize, right? And so this Recognize provides us the ability to do essentially a visible MFA where I can say, well, the user is authenticated with the application, but at what point do I want to force that user to either re-authenticate or actually go through an MFA challenge? So that may be, via push notification through the device, through whatever MFA service you use. So APM provides the data plane and provides the data integration point for this API and allows us to take an action based upon what the machine learning API is saying. So for this to actually work, one of the things we do is there's a script that would get injected into your application from the proxy itself. And we have a simple one-page wizard to control how do I want to inject that into the actual application. Don't spend any time there. But in terms of where we want to inject it, what we'll say is, well, we have a series of protected URIs. And so based upon those URIs, let's check and see if they're eligible. So that's that invisible MFA. Then the MFA check happens here. If they're eligible, we'll give them a message box and bypass MFA. If they're not, let's go ahead and do the MFA challenge. In which cases, for the demo purposes, we just did a message box. So, all right. Where's the login? Sorry about that. Okay, here we go. All right, so we're going to sign into the application. We did an MFA challenge, so submit MFA. We had never seen you before. You're an unknown user, so let's go ahead and do the MFA challenge. The user is going to submit the MFA, and then they're into the application. think I skipped ahead too far. Okay, demo gods. Okay. Any case, any questions on that? Questions, comments, concerns? Dave, you had a good question, so let's check the chat.
If anyone wants to post their questions in the chat, you can do that also.
I can find the chat on my screen here. No one? All right. With that, we will just stop the session, and we're more than happy to answer any direct questions and provide the presentation.
And Corey, if anyone wants to follow up, should they reach out to you directly, or is there someone else from your team they should go through?
Yeah, there's Lyle Marsh, who is on the call right now. He represents the federal team.
Can you
Great.
put points of contact in the chat then, Corey?
Okay, hey Lyle, if you're still out there, would you go ahead and post that in the chat?
Yep, I'll do it right now, Corey.
All right, thanks.
Thank you.
Okay, so the POCs will be in the chat. Does anyone have any other questions or comments before we wrap up a little bit earlier today? Okay, well, if no one has any questions, I'm going to stop recording then.